Hello, I believe this is day 13, and so let us get to day 13. And let me organize my windows so that they're not all screwed up the way that they were before, because that was causing me a lot of grief. So we have this, which comes down here, and then we have this, which there's not really anywhere to grab it, but I don't know what that thing that popped up was. Okay, good. So, okay, now I can get from one to the other, although not that well. Let me make this a little bit smaller and this a little bit smaller too, so that I can get in here. Okay, good. All right, day 13. No, day 14. Really? All right, I guess it's day 14. Yeah, day 14. Okay. Distress signal leads you to a giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself. That doesn't make any sense here. You don't know the path leads behind the waterfall. Correction. Direct signal leads you behind a giant waterfall. Large cave system, definitely further inside. Make your way. Ground rumble. Sand begins pouring in. If you don't quickly figure out where the sand is going, you can become trapped. For you're familiar, analyzing the path of falling material will come in handy here. You scan a two-dimensional vertical slice cave above you. Discovers mostly air structures made of rock. Your scan traces the path of each solid rock structure. Represents XY coordinates form the shape of the path, where X represents distance to the right, Y represents distance down. So each path there's a single line of text. Out of the first point of path, each point indicates the end of a straight horizontal line. 498.4, 498.6, 498.66, okay, 5034, 5024, 5029, 490.49. The scan means there are two paths of rock. The first path consists of two straight lines. Second path consists of three straight lines. Sand pouring indicate 500. Drawing rock as that, air as that, and the source of sand is pound. This becomes this. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill 1 tile of air in your scan. A unit of sand always falls down 1 step if possible. If the tile immediately below is blocked by rock or by sand, the unit of sand attempts to move diagonally 1 step down and to the left. If that tile is blocked, the unit of sand attempts to move diagonally down 1 step and to the right. Sand keeps moving as long as it's able to do so. Step trying to move down, then down left, then down right. If all 3 possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is carried back to the source. So drawing sand that has come to rest as O. First unit of sand simply falls straight down and then stops. Second unit of sand then falls straight down, lands on the first one, and then comes to rest on its left. For a total of 5 units of sand have come to rest. They form this pattern. For a total of 22 units of sand, finally, only 2 more units of sand can possibly come to rest. Once all 24 units of sand shown above come to rest, all further sand flows out the bottom, falling into the endless void. Just from the path the new sand takes before falling forever is shown here with tilde. Use your scan to simulate the falling sand. How many units of sand come to rest before sand starts flowing into the abyss below? Sand is pouring in the cave from point 500, 0. Okay. So okay. Let's do this. That's the wrong file. And see what happens. Okay. And so we'll say point is a tuple of int. That will come in handy. And let's say a path is a list of points, and parse path raw string. Okay, so let's see. No, so I don't want to do that. So I'll say for part in, I'll call this line. So maybe it'll figure out in line.split on this yield tuple map int part split. And so return I don't like using map, but but let's say path equals this for part inline dot split. Let's say xy equals part split on comma path dot append. That's what I want, and then return path. And okay, and let's say simulate sand. We'll say paths is a list of path, and then entry x int equals 500, and that's going to return an int, right? And so let us say, well, say world, which is a dict of points to string is this for path and paths. For P1, P2 in zip, yep. For X in range P2, 0. So let's say, let me call this X1, Y1, X2, Y2 in that, right? Okay, so if X1 equals X2, then we'll say Y1, Y2 equals, so we want to do it that way, right? And then for Y in range Y2, world X1, Y equals, that's fine. Otherwise, L if Y1 equals Y2, X1, X2 equals min max for that world X, Y, that seems right. Else raise value error, invalid path. And now let me abstract something out here. World is going to be a dict of point to string, and def make world paths, which is a list of path, and it's going to return a world. And now I'm going to pull this into its own function. I don't know why. I just feel like doing it. World equals make world paths. And let's say from itertools import count. Okay. So for I in count 1, so that's just going to be our counter. XY equals entry X0. Okay. And then down equals xy plus 1, down left equals x minus 1, y plus 1, and down right equals x plus 1, right? Okay. So if down not in world, then y plus equals 1 and continue. Elif down left not in world, x minus equals 1, y plus equals 1, continue. L if down right, not in world, x plus equals 1, y plus 1, continue. Else, oh, so let me, um, so right, while true. So let me do one things. I want to find when once sand is out of the bottom of the world, max y for x, y in world, right? If y is, let's say, beyond the bottom, then I want to return I. And so this just shouldn't be count 1, this should be count 0. So fell out the bottom of the world, so we're done. If I understood it correctly, I'm going to have to go back with the instructions. And then otherwise, let's say, now I'm breaking out, so I have to do falling equals true, and change this to while falling. If down not in world, falling, falling, I don't have to do continue here, I have to continue here. Otherwise, falling equals false. Actually, then I can just probably break out of this one, and I think that'll work. But what I need to do is I need to say world xy equals, and what did they call it? Sand that has come to a rest as O. Okay. And world is a hash map, so we do like this, break. Okay, so let me just go read this one time. Sand is produced when you assign X for real sand produce. Sand always falls down one step. Below is blocked. Sand attempts to move one to the left, one to the right. So sand history as long as people do so, you step trying to move down, then down left, and then right. If all three possible positions are blocked, sand comes to rest and no longer moves, at which point the next unit of sand is straight back at the source. Once all 24 units of sand can rest, all further sand flows at the bottom. So that should be 24. So let us try this, and let us say this doesn't return anything. Okay, so seriously, okay, raise value error. It's impossible to get there, but it was complaining that I don't always return an int, right? So let's say paths equals parse path line for line and raw dot split lines. Let's say print simulate sand paths, and it should be 24. So let's try that and see if it works. Run day 14.py 24. Good. So let me change that to assert simulate sand paths equals 24. And now I need to get a puzzle input. Let's see how bad this is. So this might run for a while. We'll see what happens. Okay, so now let's say with open day 14.text is f, lowercase raw equals f.read, paths equals, come on, you know how to do this, parse path line for line and raw split lines, print simulate sand paths. All right, let's do this. 888. See if that works. That is the right answer. You have to administer the scan. There isn't an endless void at the bottom of the scan. There's floor and you're standing on it. You don't have time to scan the floor. So assume that the floor is an infinite horizontal line with a y coordinate equal to 2 plus the highest y coordinate. The example above, the highest y coordinate of any point is 9 until the floor is at y equals 11. This is as if your scan contained one extra rock path like minus infinity. With the added floor, the example above now looks like this. To find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to rest at 500, 0, blocking the source entirely and stopping the flow of sand it's saved. In the example above, stops after 93. Okay, so now we need to change it, and I am probably going to just write another function because I don't feel like modifying this one. So I'll call this simulate sand 2, world equals make world pass. But now the bottom is plus 2, and the bottom is going to behave differently. Bottom behaves differently for part 2. Okay, I'm going to count blocking the source entirely. Okay, so again, now what we want to do is there's no falling. We just we can say this, change this to while true, and okay, if if y is less than bottom and down is not a world, y plus equals 1. L if y is less than bottom and down left not in world. L if y is less than bottom and down right not in world. Otherwise, it's either blocked or it's at the bottom. And if xy equals entry x 0, equals entry x 0. And now let's see if I get an off by 1 here. So if I do 1 and it falls and it blocks, that's 1. So that would return 0. So I think here I actually want to do count. No, I'll do count 1 because I'm going to stop. Unisand comes to rest at 500, 0. So let's just make sure. Print simulate sand 2 of paths. So let's run this and see if it runs correctly. It says 111, but theirs says 93, so that's not right. So def show world, which is a world. Okay. It's going to print a lot of stuff, but that's okay. And let me print so that I get a clean break. So because I'm going down too far, Uh, so y is less than bottom minus 1, um, and y is less than, so actually let me change bottom then. This is bad. Um, okay, so now let's run it again, and I got 93. And so 93 I think was the right answer, right? Um, let me just move this to um, and try it again. Okay, so now I think that looks exactly like their thing. So um, I will not do that. I will assert that it equals no, that equals 93, and then I will print simulate sand to a pass. Okay, so 93 is the right one. 93. 26461. So let's try that. That is the right answer. All right. So that was all right. I had to draw a picture to figure out my off by one errors. I had some off by one errors, but otherwise it was relatively straightforward following the instructions, right? You know, you can think about how do I want to represent all this sand, and one way to do it would be with an array of arrays. One way to do it is just with a dict. It turns out it didn't matter keeping track of what was there as long as something was there, which is fine. And then simulate the following. Just had to bless me. Just had to follow instructions. Um, you know, step, 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 step. And then for part two, obviously, when you have like an infinite line at the bottom, you can't put those all in the dictionary to keeping track of things. So we had to add this extra check of, you know, as long as I'm above the bottom and I'm not blocked, I can fall. As long as I'm above the bottom, I'm not blocked, I can fall, and whatever. I got it off by one the first time because, you know, I did, and then it worked. So that was that. Yeah, not not much to it really. I mean, there's some to it, but not not a lot. So thanks for watching, and I will see you next time. Actually, tomorrow is NormConf, which is like all day long. So I will probably not be live coding tomorrow because NormConf starts at like 6:30 in the morning my time and ends at like 8:30 at night my time. So I will probably just do a double dose of this on Friday. I may even do it all as one stream, depending how it goes, or I might break it in two. But um, I'm not working on Friday, so I can take my time.